The Himalaya, Rockies, Alps. Nothing inspires awe like these mountains. Their jagged peaks seem to define permanence. The fact is, these towers are slowly changing under our noses. Rugged mountains are relatively young. Older ranges, like these gently rolling Appalachians, may have once stood as tall and majestic. But wind and water have slowly and steadily ground down their peaks and smoothed out their rough edges. These same forces slowly but constantly act over the entire surface of the Earth. No place is exempt from weathering. Buffeted by wind and by rain, rock crumbles. Water seeps in cracks and freezes, splitting stone. Rivers carve through the land. Glaciers grind through valleys. Wind carries away sediment. And acidic water dissolves stone, leaving behind enormous caves. Erosion moves this weathered material from one place to another. Rivers and glaciers not only carve up land, but carry it miles away. Eventually, erosion provides the raw material for new land. When we look at a landscape, we usually see trees, grass, and plants. Without soil, these would not exist. Soil is created when weathered rock combines with decomposed plants and animals. Soil is a product of erosion, but it's also a victim. Rivers and floods remove soil and carry it downstream. With deforestation, overbuilding, and poor farming practices, people can intensify this loss. In the 1930s, giant black clouds of eroded soil blew off the Great Plains. This ecological disaster forced over 2 million people off the land and left it barren for years. These forces create as well as destroy. Erosion is a sculptor. It carves spectacular forms, canyons, spires, and arches. These monuments testify to the power of wind and water, forces which continually shape our Earth. "18,000 years ago, massive glaciers locked 1/3 of the land on Earth in their icy grip. These rivers of ice gouged their way through mountains, smashed boulders to bits, and scoured areas of the Earth flat. Then temperatures began to rise. The glaciers began to retreat, exposing a changed landscape. Glaciers helped form the lakes and rich soil of the Midwest, the fjords and peaks of Patagonia, and Yosemite Valley in California. Here, the glacier bulldozed its way through the mountains, carved out a U-shaped valley, and left behind sheer cliffs like Half Dome. A glacier begins when snow begins to fall faster than it melts. As the snow accumulates weight, it compresses. The light, fluffy crystals turn into firn, a dense, grainy ice. As years go by, the weight of accumulated snow on top increases. The ice begins to move under its own weight. No speeding tickets here. The glacier moves under 1 inch per day. The bottom layer, slowed by the ground, moves less than the top. The strain cracks the ice, creating giant crevasses. Warming at the end of the last ice age reduced the Earth's glaciers, but it didn't get rid of them. Today, more than 1/10 of the land is still covered in ice, and that ice holds a wealth of information. Scientist Keith Eckelmeyer measures Columbia Glacier in Alaska yearly in order to get a jump on global climate trends. Columbia has retreated 8 miles from its terminal moraine, the pile of rubble left at the end of the glacier. As it shrinks, it calves huge icebergs off into the sea. No one knows for sure whether this is from global warming or just part of the natural cycle of temperature and ice. By studying air trapped in the ice, researchers reveal the history of Earth's climate and look past the current warmth for clues to the next ice age. They provide us with challenge and adventure, serve as highways, sustain our crops, and shape the land. Rivers have always been central to human life. Our earliest ancestors found food and water here. Rivers created the fertile soil that spawned agriculture and trade. Early, great civilizations arose along storied rivers. The Nile made Egypt possible. Today, cities like London, New York, Shanghai, and Cairo all sit astride rivers. Every river has a source. It may be melting snow, a lake, or a spring. In most rivers, water flows downhill into small streams. These streams feed into one another, gathering strength and speed. This flow carves and shapes the land, breaks up rock, and cuts channels. The river is steep and fast at this stage, powered by gravity. Eventually, a river settles down. It levels out and slows. The river begins to form a pattern of loops. The current slows down on the inside of each loop, causing eroded sediment in the water to drop. On the outside, greater friction continues to erode the banks. The river widens, and this pattern of meanders intensifies. Near the end of its journey, a river slows even further. At this stage, it cuts less land and drops more sediment. As it empties into a sea or a lake, it may deposit so much sediment that it forms new land, a delta. A river is a dynamic, ever-changing force. Its level drops and rises. It changes shape and speed. Sometimes, these changes don't necessarily fit into our plans. But without rivers, the Earth wouldn't be the same. This kind of damage spurs a mammoth effort to control the Yangtze. Over the last 16 years, 40,000 workers have labored to build the Three Gorges Dam, the world's largest. Workers pour 50 buckets of concrete a day, each carrying 20 tons. They build the dam one giant block at a time. When it's finished, the dam will generate enough electricity to power 4 cities the size of Los Angeles. An enormous elevator will be able to raise a ship the height of the dam in 42 minutes. And the dam will create a 400-mile-long reservoir. These achievements come with a price. The dam will submerge hundreds of communities along the river, displacing over 1 million people. Some say the dam will change the flow of silt, perhaps increasing the risk of floods upstream. Dams also affect wildlife, destroy habitat, and interrupt the migration of fish. It's these unpredictable costs that make dams controversial. As our engineering ability increases, so do the unintended consequences. But as long as rivers rage, people will try to control them. It's the land of cotton, shrimp, and catfish, Cajun swamps, and New Orleans. The Mississippi Delta, where the river meets the sea, is a place like no other. The Delta is more than a state of mind. It's a geological phenomenon. Deltas are flat, low-lying plains that sometimes form at the mouths of rivers. A river carves and carries bits of clay, dirt, rock, and sand as it runs its course. The Mississippi moves as much as 200 million tons of it. As the river approaches the sea, it widens, its currents slow, and all that sediment falls to the bottom. Then the river shifts, building up material in another direction. From space, a delta looks like giant fingers fanned out from an outstretched hand. People still rely on the bounty offered by deltas. The rich soil creates ideal farmland, and the surrounding wetlands provide a natural system of flood control and host a rich assortment of wildlife. If there's one thing to keep in mind when living in a delta, it's this: slow but constant change. Like a hose moving back and forth, water changes course, building up sediment in one place and then another. Where soil isn't replenished, it sinks. When this fort outside New Orleans was built 200 years ago, it was 1,000 yards inland. No place demonstrates the precarious balance between people and nature like New Orleans. In 1828, a builder named Henry Shreve broke a log jam separating the Mississippi River from the Atchafalaya. He hoped to increase New Orleans' trade, but instead threatened its existence. Since the Atchafalaya offers a shorter, steeper route to the sea, the combined waters increasingly flowed its way. Unchecked, the Atchafalaya would capture the Mississippi away from the city. Only a government-ordered system of levees and dams keeps the river flowing past New Orleans. There's more. Built on soft delta sediment, the city is sinking. It now sits 15 feet below sea level, kept dry only by levees. It's an unescapable reminder that this land is nothing but a 4-mile deep layer of mud, built by a river, on its way to the sea.